Hi, it's Mr. Wagner. In the last video, we discussed atoms. We said that all matter is composed of atoms, and there are three major classifications of matter. Elements are the simplest pure substances that cannot be broken down. Compounds are pure substances that have two or more elements chemically combined together. And mixtures are substances that are not pure. They are not chemically combined. They just happen to be in the same place. We also identified the three subatomic particles, the protons, neutrons, and electrons, and gave a brief history of the evolution of atomic theory. Over the next few videos, we will be discussing atoms as they relate to the periodic table. But before we get too far, it's important for us to understand the relationship between atomic particles and certain characteristics of atoms, such as atomic number and atomic mass. Mortimer, can you refresh everyone's memory as to what a proton is?
Yes, a proton is a relatively large, positively charged subatomic particle that's found in the nucleus of an atom. And the number of protons in an atom determines what element you have, also known as the atomic number.
Excellent. The atomic number is the number of protons, and it does determine the element that you have. Guy, what are electrons, and where are they found?
Electrons are a lot smaller than protons. They have a negative charge, and they're found in the cloud-like region. They orbit around the nucleus, and the number of electrons is equal to the number of protons.
Great job. Electrons are negative, and neutral atoms have the same number of protons and electrons. So that leaves just the neutrons to discuss. What can you tell me about neutrons?
They're found in the nucleus of the atom.
And they have no charge, but they are about as big as a proton.
Great. So we have the atomic number, which is the number of protons. And the number of protons is also the number of electrons if the atom is neutral, which we will assume it is. Protons are about the same size as neutrons, and they're both larger than electrons. If we add up the mass of the protons and the neutrons, we get the atomic mass. Let's give this some practice. Mortimer, here is the symbol for the element helium. What can you tell me about it?
Well, helium has an atomic number of 2, so it has 2 protons. And since it has 2 protons, it also has 2 electrons. And it must also have 2 neutrons because it has an atomic mass of 4, and 4 minus the number of protons gives you the number of neutrons, which is 2.
Excellent. Now, Guy, I would like you to pick an element, any element on the periodic table.
Gold.
Are you sure you want to go with gold?
Yeah.
Okay.
Yikes. Okay. The atomic number is 79, so it has 79 protons. And there must also be 79 electrons, so the atom has to be neutral.
What about the number of neutrons?
Well, it has 197 for its atomic mass, and 79 of those particles are protons. So you take 197 and you subtract 79, and you get 118 neutrons.
Great job, Guy.
Mr. Wagner, doesn't the periodic table say that the atomic mass of chlorine is 35.453? I beg your pardon, but I can't have 0.453 neutrons. How is that possible?
The atomic mass number that you find is actually an average of all the isotopes that are found in nature for that element. So it means that most of the chlorine in the universe is chlorine 35, And there's also some that's chlorine-37, and rarer varieties as well. We find the average of all of these isotopes, and it just happens to be for chlorine, 35.453.
So how do we know which isotope to use for our worksheet?
Good question. For this class, we will simply round the atomic mass to the nearest whole number. So you can say that chlorine has an atomic mass of 35.
So it has 17 protons and 18 neutrons.
Correct.
Okay, I get it now. Thanks.
So now let's get some practice with determining the subatomic particles in elements. Here we have hydrogen. The number on the top right is the atomic number. This tells us there is one proton in an atom of hydrogen. And since there's one proton, there must also be one electron. We round the atomic mass, which is 1.01, down to 1. That tells us that the total number of protons and neutrons in the nucleus is 1. And since we know there's already one proton there, we know that there are 0 neutrons in this atom of hydrogen. Next, we have potassium. Potassium has an atomic number of 19, which tells me there are 19 protons, and therefore there must also be 19 electrons. The atomic mass rounds down to 39, and since there's already 19 protons in the nucleus, 39 minus 19 gives us the number of neutrons, which is 20. And finally, krypton. Krypton has an atomic number of 36. There's 36 protons and 36 electrons. The atomic mass rounds to 84. And since there's 36 protons in the nucleus, 84 minus 36 gives us 48 neutrons in the nucleus.